Okay, so the histograms represent the masses of 500 mice. If you look at it, we've got birth masses on the bottom and frequency density, and we want to work out the masses for below 10 grams. So if you look at the frequency density on the left-hand side, it doesn't actually have a scale, so that is where the problem lies. If we count up the squares then, we could call that 3x, and the other height for the histogram would be 8x, and so on. So 11x, 23x, 19x, and 2x, because they're just unknown heights. We can't do any calculations until we know those heights. We know the widths of those. We've got 4, 2, 2, 1, 1, and 4 on the final width. Now we know this, we can actually use some calculations. So back to the first one, we've got 3x and 4. So the area for that section of the histogram would be worth 12x. If we look at the 8x and 2, that's going to give us 16x. And then 22x, that's 11x times 2. 23x, 19x. And 4 lots of 2x, the final one being 8x. Now those areas from the question add up to 500. Okay, so you can see it in the question, they add up to 500. So that must equal 500. Now if we were to add those all together, just quickly, I'll do the maths for that, you would end up with 100x equal to 500. And you can see straight away that x must be 5, but if you need to solve and divide by 100, then either way you do it, you will get that x is equal to 5. This is really important, however, we need to make sure we're clear on what the question is now asking. So it says below 10 grams. So if we look in there, we've got below 10, so it's all of that area which I've just pointed out, so I'll shade it. Now if x is 5, that section which says 3x times 4, actually the 3x now becomes 3 lots of 5, so that's 15 in terms of the height, and it's still got a width of 4. So 15 lots of 4, giving you an area of 60, so it represents 60.